Welcome to Two Projects. In this video, we are going to explain the project Handwritten Gujarati Numericals Classification based on Deep Convolution Neural Networks using Transfer Learning Scenarios. Introduction. The project focuses on the development of an optical character recognition that is OCR system tailored for the classification of handwritten Gujarati numericals. Given the linguistic diversity of India and the prevalence of paper documents in regional languages, the need arises for efficient conversion of handwritten content into a computer readable format. So, the primary objective is to address this challenge specifically for Gujarati numericals, which poses unique difficulties due to variations in writing styles. In the digital era, organizations, including both government and private sectors, strive for paperless work. However, handwritten documents in regional languages such as Gujarati continue to be collected by institutions like banks, post offices, and government offices. So, this project's significance lies in developing a solution for converting handwritten Gujarati numericals into machine readable text, facilitating seamless integration into the digitized workflow of various sectors. And by leveraging the power of deep learning, the project employs convolutional neural networks CNNs for image classification tasks. Three transfer learning scenarios are employed using 10 pre-trained CNN models including LayNet, VGG16, ResNet 50, Inception V3 and others. The transfer learning strategies involve adapting the pre-trained models to effectively classify handwritten Gujarati numericals. And the project has multiple beneficiaries, including government and non government organizations, banks, post offices, and any institution dealing with handwritten documents in Gujarati. The successful implementation of the OCR system will streamline data entry, enhance accuracy, and expedite document processing. Ultimately, this technology can contribute to the broader goal of digitization and modernization across various sectors, saving time and resources while ensuring efficient handling of handwritten content in regional languages. Objective of the project. So, as I mentioned earlier, the primary objective is to create a robust optical character recognition that is OCR system tailored specifically for Gujarati numericals. This system aims to effectively handle the challenges presented by diverse writing styles prevalent in a multilingual context, with a particular emphasis on addressing the gap in deep learning research for Gujarati numericals in India. And the project aims to explore and implement three distinct deep transfer learning scenarios using 10 pre-trained convolutional neural networks architectures. So the focus is on optimizing the fine-tuning process, specifically determining the depth at which to adjust pre-trained models. This optimization is crucial for achieving effective recognition of handwritten Gujarati numericals. And the goal is to thoroughly assess the performance of the developed OCR system. This involves evaluating the transfer learning scenarios and pre-trained models using a dataset of Gujarati numerical images ranging from 0 to 9. Key metrics such as training accuracy, testing accuracy, F1 score, precision, and recall will be highlighted to provide a comprehensive understanding of the system's effectiveness in recognizing and classifying handwritten Gujarati numericals. Requirements needed to execute this project are software requirements. Software needed is Anaconda. Primary language used is Python. Front-end framework used is Flask. Backend framework used is Jupyter Notebook. Database used is SQLite 3. And front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working modules of flow of work. So the first step is importing required packages. So the project initiates by importing essential packages, establishing the foundational tools necessary for subsequent data processing, image handling, and machine learning tasks. This step ensures that the project has access to the required libraries and modules for seamless execution. The second step is exploring the dataset. In this phase, the project delves into the exploration of two datasets, one containing handwritten Gujarati numericals and another sourced from HG RoboFlow data. Thorough examination of these datasets lays the groundwork for subsequent image processing and model training. The third step is image pre-processing. So, image processing is crucial for enhancing the dataset and improving model robustness. Leveraging the image data generator, the project employs techniques such as rescaling, shear transformation, zooming, horizontal flip, and reshaping. Additionally, torch vision based processing is implemented, specifically designed for detection tasks. The next step is training and building the model. So, the core of the project involves training and building models for handwritten Gujarati numerical classification. Various architectures, including ResNet 101, DenseNet 169, MobileNet V2, ResNet 50, VGG16, Inception V3, Exception, MobileNet, LayNet, and EfficientNet V2S, are explored. The focus is on achieving optimal classification results using SVM loss function, softmax, and fine tuning. And in the next step, as an extension, the project incorporates object detection capabilities. YOLO V5 and YOLO V8, two state of the art detection models, are introduced. This extension enhances the project's versatility, enabling it to handle not only classification but also object detection tasks. And the project extends its functionality by developing a user friendly front end interface using the Flask framework. The inclusion of user authentication features powered by SQLite ensures a secure and personalized experience for users during testing and analysis. So, after signing in, users are facilitated to upload images for analysis through the front end interface. The input images undergo pre processing steps, ensuring compatibility with the trained models and setting the stage for accurate recognition. And the diverse set of trained models encompassing various architectures collaborates to provide accurate recognition and classification of handwritten Gujarati numericals. And the final results are displayed through the front end interface. So, results are displayed in a user friendly manner, showcasing the effectiveness of the OCR and detection models in recognizing and categorizing handwritten Gujarati numericals. Now we'll understand about the algorithms used. So the first algorithm built is ResNet 101. So ResNet 101, a deep convolutional neural network featuring 101 layers, is renowned for introducing residual connections that alleviate the vanishing gradient problem in deep networks. In the context of recognizing handwritten Gujarati numericals, its depth and capacity to capture intricate features make it a suitable candidate, contributing to accurate and robust classification. The next algorithm built is DenseNet 169. So DenseNet 169 stands out for its densely connected architecture, introducing dense blocks where each layer receives direct input from all preceding layers. This design promotes efficient feature reuse and improved gradient flow, making it highly relevant for recognizing complex patterns in handwritten Gujarati numericals while maintaining parameter efficiency. The next one is MobileNet V2. So, MobileNet V2, designed for mobile and edge devices, employs depthwise separable convolutions to reduce computational load while preserving performance. Its lightweight design and efficiency make it well suited for real time applications, ensuring quick and accurate predictions for the recognition of handwritten Gujarati numericals. The next algorithm built is ResNet 50. So, ResNet 50, a variant of ResNet with 50 layers, strikes a balance between model complexity and computational efficiency. Widely adopted, it incorporates residual connections to enable training deep networks, making it suitable for the project's goal of accurate recognition without excessive computational demands. The next one is VGG16. So, VGG16, a classic convolutional neural network with 16 layers, is recognized for its simplicity and uniform architecture. Leveraging small convolutional filters and deep stacks of layers, VGG16 can effectively capture hierarchical features, making it a suitable choice for recognizing patterns in handwritten Gujarati numericals. The next algorithm built is Inception V3. So Inception V3, part of the Inception family, utilizes Inception modules with filters of multiple sizes in parallel to capture features at different scales. This design aims to balance computational efficiency and high performance, contributing to the recognition of nuanced details in handwritten Gujarati numericals. The next one is exception. So, exception extends the inception model by replacing standard convolutions with depthwise separable convolutions, enhancing model efficiency and parameter sharing. Its architecture is tailored for efficient feature extraction, making it relevant for capturing features effectively in handwritten numerical recognition. The next algorithm used is LeNet. So, LeNet, an early convolutional neural network, is designed for handwritten digit recognition. With a simple yet historically successful architecture, LeNet is a suitable candidate for recognizing Gujarati numericals, leveraging its proven effectiveness in recognizing handwritten digits. The next one is EfficientNet V2S. So, EfficientNet V2S, part of the EfficientNet family, employs a compound scaling method to balance model size and performance efficiently. Its design allows for optimal utilization of computational resources, making it a valuable choice for achieving accurate recognition of handwritten Gujarati numericals while optimizing efficiency. And the last algorithm built is MobileNet. So, MobileNet is designed for mobile and edge devices focusing on efficiency. It utilizes depthwise separable convolutions to reduce computational complexity while maintaining performance. In this project, MobileNet is chosen to ensure real time processing efficiency in the recognizing of handwritten Gujarati numericals, particularly in resource constrained environments. And in this project, we adopt three key techniques for training these models to recognize handwritten Gujarati numericals. So, firstly, we employ the SVM loss function, a classification loss metric, to effectively train the models by penalizing misclassifications and promoting the learning of distinct decision boundaries between numerical classes. Secondly, the soft max activation function is utilized to transform raw output scores into probabilities, facilitating the interpretation of the model's confidence in predicting each numerical class. And lastly, the fine tuning technique is crucial for adapting pre trained models, including ResNet 101, DenseNet 169, and others, to the specific task of recognizing Gujarati numericals. Fine tuning leverages knowledge gained from broader datasets, optimizing the models for the nuances of handwritten Gujarati numericals and enhancing the performance in the absence of abundant task specific label data. Now we'll see the comparison graphs. So, first, we'll see the comparison graphs of the algorithms built for classification using SVM loss function. So, this is the horizontal bar graph comparing accuracies of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. So accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. So precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis, I have recall scores and on y-axis I have algorithm names. So recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F1 scores comparison graph. In this graph on x-axis, I have F1 scores and on y-axis I have algorithm names. So F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So these are the comparison graphs of the algorithms built for classification using softmax technique. And these are the comparison graphs of the algorithms built for classification using fine tuning. So the algorithm which is best performing in all the performance metrics will be used for predictions. Now we'll see the comparison graphs of the algorithms built for detection task. So this is the recall scores comparison graph. In this graph on x-axis, I have recall scores and on y-axis, I have algorithm names. So recall assesses the model's ability to capture relevant instances calculated as the ratio of true positives to true positives and false negatives. This is precision scores comparison graph. In this graph on x-axis, I have precision scores and on y-axis, I have algorithm names. So precision measures the accuracy of positive predictions representing the ratio of true positives to the sum of true positives and false positives. And this is MAP scores comparison graph. In this graph on x-axis, I have MAP scores and on y-axis, I have algorithm names. So MAP, that is mean average precision, evaluates object detection performance by calculating the average precision for each class and then determining the mean over all classes. So the algorithm which is best performing in all the performance metrics will be used for detections. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is dataset folder in which I have required dataset for detection task. This is the dataset folder again in which I have required dataset for classification task. This is sample folder in which I have images on which we will make the detections. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And these are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. And these are Jupyter source files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. So now use the command cd followed by space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. So this is the local host and this is the port. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on submit button to register. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password and click on submit button. So it has redirected us to the classification page. So here we can see a prediction link, click on it. So as I mentioned earlier, we can perform both classification and detection tasks in this project. So first we'll perform the classification task, click on it. So here we have to upload the Gujarati handwritten numerical image and the application will convert it into a readable format. Click on choose file button. So from sample images folder, I'm selecting this image and click on open. So the image is loaded. Now click on upload button. This is the uploaded image, and here we can see the classification. So the application has classified this Gujarati numeric as number 8, and it has also given the Gujarati script of it here. So we'll try again, click on try again link. We'll try giving another image, click on choose file button. So this time I'm giving this image and click on open. So the image is loaded. Now click on upload button. This is the given image, and here we can see the classification, that is 4. We'll try again, click on try again link. Click on choose file button. So this time I'm uploading this image and click on open. So the image is loaded. Now click on upload button. This is the uploaded image, and here we can see the classification. So the application has classified this Gujarati numeric as number 1. And we can also see the Gujarati script of it here. Now click on prediction link. We'll perform detection task. Click on detection link. So we have to upload the Gujarati handwritten numerical image again. Click on choose file button. So this time I'm selecting this image and click on open. So the image is loaded. Now click on upload button. So we can see the application has detected the Gujarati handwritten number, and it has drawn a bounding box around it, and we can see the classification, that is 9. So this number is classified as number 9, and we can also see a probability score here, which tells us how confident the application is about the detection. Click on back. We'll try again. Click on choose file button. So this time I'm uploading this image and click on open. So the image is loaded. Now click on upload button. So we can see the application has detected the Gujarati handwritten number. It has classified it as 7, and it has drawn a bounding box around it. And we can also see the probability score. Now click on back. So similarly, we can upload any image, any Gujarati handwritten numerical image, and can get the detections and classifications. Now click on sign out. So the conclusion here is the project successfully addresses the challenge of recognizing handwritten Gujarati numericals by implementing a diverse set of models including ResNet 101, DenseNet 169, and others. The utilization of techniques such as the SVM loss function and softmax activation contributes to accurate and reliable classification. Fine tuning pre trained models on the specific task of recognizing Gujarati numericals proves to be a pivotal strategy. This technique enhances the model's adaptability to the nuances of the script, leveraging knowledge gained from broader datasets and optimizing their performance. The project extends its capabilities beyond classification by incorporating detection models like YOLO V5 and YOLO V8. This extension broadens the scope, allowing the system to not only classify but also detect handwritten Gujarati numericals within images. And with the implementation of a front end interface using Flask, the project ensures a user friendly experience for testing and analysis. The integration of user authentication features enhances security, providing a seamless interaction for users uploading images for analysis. So, these collective efforts contribute to an effective optical character recognition, that is OCR system, tailored for handwritten Gujarati numericals, paving the way for broader applications in document processing and digitization.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.